Welcome, everyone. Today, we're going to be talking about shell scripting, which is one of the most powerful ways to automate tasks in Unix and Linux. So, what exactly is a shell script? A shell script is a file with a sequence of commands. So, instead of typing commands one by one, you can save them in a file, and then the shell interprets that file line by line. But that does mean that they're slower than a program such as C or Java. However, they're also much faster to write and test. Here's an important thing to remember. If the shell finds a syntax error, then the shell script will stop immediately. So it's really important to keep in good habits like checking your shell scripts with tools to make sure that they are error-free. Also, to run a shell script, you need to make sure that it's executable. For example, you might run chmod 755 and then the file name, which will make it executable. And then you can run it in a few ways. The first one is just by its name if it's in your path. The second way is by typing a period, forward slash, and then the name of your shell script, .sh. And the third way is simply by typing the absolute or that full path to your shell script. Let's start by making a quick script so you can see how this works. I'll create a file, add a command, and then run it. So let's just start with echo. I'm going to put in this script, echo hello, end quote, then write it to a file called test.sh, hit enter. Now I'm going to make that file executable. And then finally, I'm going to run it. So period, forward slash test.sh. And look, so when I type echo hello, that's literally telling my computer to write the word hello. And so when I execute that script, that's going to be the output right here. Because the file just contained that one command, that's the one command that the bash executed. Now take a look at this slide and see if you can create the classic hello world script on your own. I'll come back in a second and show you how I do it on my end, and if you did yours correctly, it should look a lot like mine. To start with our script, first make sure that you are in bash, and then secondly, you're going to create the script called hello.sh by typing vi hello.sh. Hit enter, and then make sure that you're in insert mode. So you'll see down here, it should say insert, and then you're going to add what's called a shebang, which is what we start off every bash file with, which in the case of a Mac, for example, in my system, and probably your system, is the # exclamation point /bin /bash. Then you can comment here with the # prints hello world. That comment is just a comment, so it's not going to actually affect the script and how it runs itself. And then I'm going to type in our echo line, which is echo hello world. Get out of the insert mode by clicking the escape button. So remember to write it first to save your changes, and then quit, hit enter, and that should save your script. Now let's make it executable. To do this, we can go chmod, and then for execute permissions, we can type +x, which is execute, and the name of our file, which is hello.sh, enter. And then let's start with period / hello.sh. When I hit enter, it's going to execute. And see, we've got our print statement there, which is hello world. Notice that I typed the period and /. Why do we have to do this exactly? Well, the shell only looks for commands in the directories stored in our path. You might also see that as $sign written out. That looks like a $sign and then path in all capitals. And if a script isn't in one of these directories, then the shell won't find it. You can also check your path with echo $path, and it's simply just a colon-separated list of folders. So here, if I type $path. It's just going to show everything that's in my path. Now here's a good convention, which is making a folder called bin inside your home directory. We can use our command mkdir, make directory, ~bin, and then add it to our path. Let's see this in action. Let's create a personal bin folder and add it to our path. So again, we'll start with making the directory with the ~bin. This is where I'll be keeping my personal scripts. Then I'm going to write echo path equals $path $home /bin, end the double quote, and then end the single quote, and then two greater than signs, tilde, /period, bash, profile. So what this is doing is we're appending a line to our bash profile. So this is the line, and this is our bash profile. And this line is saying to add bin, which is this right here, to our path. Notice that I use $path. What this does is it preserves that old path and adds my path to the end of it. So I'm going to hit enter. Now in my case, when I hit enter, it actually showed an error. As you can see, it says permission denied. Why is this exactly? Well, my bash profile is actually owned by the root and not by my own user, which is Devin. So to change this, what I need to do is run sudo, which lets me run the command as a root user, chown, and using Devin staff, which means that I've set the owner to the user Devin and the group to staff. And then this part again, so the ~period bash profile. Now I'm going to type in my own password. And after this, the file should be readable and writable by you. So let's check our ownership to see that that bash profile now is owned by me. So I'm going to type ls-la, because again, that's going to show us all of those permissions and the name of our file. Enter and see. Now we see that Devin staff is the owner. Now let's write echo export path to that bash profile. So that way, whenever the path variable is exported, the shell and any subshells will use it. By typing source and then this bash profile, this is going to reload our profile without having to log out of our terminal here. And now path includes my new bin directory. As I mentioned, you can move your shell scripts to your bin directory. So if you move hello.sh into the ~bin using the mv command, then you'll be able to type hello.sh from anywhere and it'll run. And that's how the system commands like ls and pwd also work. They're simply executables in the directories that are on your path. Now, as I mentioned, it's important to not have any syntax errors in your shell scripts. Shell check is a static analysis tool. It's essentially a linter for bash. So on Ubuntu, you can install it with sudo apt install shell check, and then with Mac, you can use brew install shell check. If you don't have brew installed, so it shows some sort of error, then you will need to install homebrew. And I'll put a link to those instructions in the description. Once you install that, you can try shell check hello.sh for that previous example, and it will flag any mistakes you might have, show best practices, and in general help you write safer scripts. So it's kind of like spell check, but just for shell. Now let's try out some logic by putting some conditional expressions inside a shell script. What I want you to do is try to create this file on your own. I'll put this code in the description, and you can simply create your own if.sh file, and I will shortly show you how I did it. So again, first, I'm going to make my file vi if.sh. I'm going to enter insert mode, and then I'm just going to paste what is in the description and on that side into my shell script. Again, We have the shebang just like before, which is that line up here. Then we have color equals $1. So I'm assigning the first command line argument into a variable called color. The $1 always means that it's the first argument. Then we have this if statement, which says that if the value of our variable color equals the string blue, then do the following. So we have that then echo, which means print, it is blue. If the color is equal to the string red, then it's going to print it is red. If neither of these first two conditions are true, then it will print no idea what this color is. Then finally, to close this block, we're going to type fi. Then I'm going to exit insert mode, make sure that I write and then quit, enter, make that script executable, if.sh. Then I'm going to do /if.sh. Now, as you might recall, we had that if statement with various string values. So if I type blue here, it should print it is blue. And if I press the up arrow and change this to red, it should print it is red. However, if I do the same thing, but I type yellow, it's going to say no idea what this color is because the string yellow was not one of the strings that I had given a specific print statement to. So to recap on what we just did, an else if or an elif statement is optional. And what it means is after you've taken a look at that initial if statement, if that condition isn't true, then you'll move on to the elif statement and see if that's true. And you can also add multiple elif statements after one another, and it'll simply go in sequential order. However, if you have an else statement, which is kind of like that final statement that you might have, so in our case, it was no idea what this color is, don't include a then statement after that. And then to end the entire if statement, you can simply write the word if spelled backwards, which is fi. So this slide is just summarizing what we just did. Again, values are passed into the variable denoted by $1. If there happen to have been two arguments that we wanted to use, then the second one would be denoted by a $2. Now say that you want to create a script that takes input interactively. Here's an example of what you can do, and for time's sake, I'm just going to go through it really quickly. Now take a second to pause the video and try this exercise on your own. I'm going to create a file called reader.sh, enter the insert mode, and then again, I'll have this text in the description, paste that in, and what each line is doing. So again, this is our shebang, that first line that we always put. Second is echo your first name. So this is going to print a prompt asking for the person's first name. This read-r FNAME means that when the shell is executed, it's going to pause and wait for user input. And then whatever the user types will go into the variable FNAME right here. So FNAME right there. Then the -r option prevents backslashes from being interpreted. We have read-rp, enter your last name, LNAME. Now it's doing the same thing, but with the -p option, which shows the prompt on the same line as the other prompt. And then we're just going to print out the first and last names together. So I'm going to save this. Again, make sure that the script is executable. And then finally, I'm going to do // because I haven't added it to my bin yet. I need to do that / reader.sh. My first name is Devin. My next name is Miller, and that's my name, Devin Miller. Now take a second to pause the video and try this exercise on your own. This is simply a variation that will check if the input is empty. And you can call it name, as you can see right here, just comment it as the name of the file. Because you're using the -n to check if the string is empty, This is considered a basic form of validation. So I'd like you to try and test now your name.sh script and try running it twice, once when you type your name and once when you just hit enter. You'll see the conditional logic in action, and also don't forget to run shell check on it, just to make sure you don't have any errors. When comparing numbers, you're not going to use the normal equal sign. You'll actually use -eq, and this value will be true if the values are equal to each other. On the flip side, if you use -ne, it'll return true if the values are not equal to each other. Then we have our greater than, less than, greater than or equal to, and less than or equal to. For part of your homework assignment this week, I'd like you to write a script called max.sh that will take in two numbers and print the larger one. As a hint, you might want to use that -gt or greater than operator that we just went over in the previous slide. Another practice script that I would like you to create for your homework is the newlyweds.sh file, and the idea is to take two names or answers and print a playful message. Bash also gives you a bunch of special variables automatically, so $0 is the name of your script, $1 through 9 are the names of the first 9 arguments, and you can read the rest of these to see exactly what each of these special variables do. As mentioned earlier, if you want to create a comment, you can simply start it with this £, and then in general, professional scripts begin with a block of comments, which give things like the script name, the author, the purpose, and the date, and this just makes it easier for other people to read your code. You can also use comments to explain variables or file inputs and outputs or logic that you might have. And in general, make sure that you are commenting why you did something, not just what you did, because when you look back at your own code or somebody else looks at it, it's really important to be able to quickly understand what you were thinking at the time and why you put what you put. Now, just a few sample guidelines for naming shell variables. Firstly, don't put the $sign in the name. Secondly, you'll want to pick descriptive names. So, for example, if you are creating a variable for a username, you might name it username. It would be a lot harder to go back and see what you meant by that variable if you just named it something general such as X. Also, make sure that you're consistent with your capitalization and use underscores instead of spaces. One final tip is that variables you set inside a script don't automatically exist for other programs. If you want them to be available to child processes, then you need to export them using this export syntax. Now that just about wraps up today's lecture. Thank you for listening and have a great day.